I have no idea what time I'm supposed to start, so I'm going to start now. I think it was supposed to be 15 minutes ago. Sorry, I don't know what's going on. So thanks for coming to this talk. This is about the FN project and open source serverless computing. So I'm going to talk a little bit about serverless computing, what it means, where it's going, and then I'll talk about the FN project, which is one of the options out there for achieving functions as a service. I am currently at Oracle. I was previously, actually, I have a whole intro slide on this one. So a little bit about me. I am an engineer and a builder. I'm an entrepreneur. I was formerly with a company called Iron.io, and we did like this acquisition thing, kind of pseudo acquisition with Oracle. So we joined Oracle about 18 months ago to start the serverless org, the engineering org for serverless computing. You can blame me at least partially for the term serverless. You know, it's kind of stupid. We started talking about it in 2011. I had some people that were working with me who are, really good marketers, and we thought it would be a really funny term to write a bunch of articles called "The Future is Serverless." And so here's a couple of them from Hacker News. Building a serverless search engine from 2011. I think that's actually from 2010. And why the future of software and apps is serverless. We really had no idea it was going to be this like thing, and it became this thing. So that's kind of neat. There is one person who talks about, he built, this guy, Simon Wardley, built something in 2006 called Zimkey, which is like the first version of FAS, which he called Frameworks as a Service. And now the market is becoming more rich and full with the cloud providers doing things like Amazon Lambda, Google Cloud Functions, IBM OpenWhisk, FN projects. So I'll talk a little bit about all of that. I have a pretty simple definition for serverless. I mean, these things evolve over time. I'm strong opinions weakly held, I guess. And this has certainly been evolving. Serverless, obviously there are servers, so that's like the first thing. But if you look at cloud is not in the sky. It's here in data centers. It's just about outsourcing infrastructure. Serverless just takes it up a notch and says, well, the infrastructure is somewhere else, but so is the scaling and load balancing and networking and storage and all that. We're actually not even going to think about virtual machines anymore. So this is a pretty broad definition. It's actually, right now it's like serverless washing. Everyone talks about it. But it's really about outsourcing undifferentiated heavy lifting, such as infrastructure, operations, scaling, patching, all of that stuff. It's really about owning less. And the less you own, the more you can spend time on the things that you care about, like writing code. And that's really what we're here to talk about, is writing code and spending less time worrying about things like virtual machines and how to scale them and how to load balance traffic and how to secure them and how to patch them. And I mean, yeah, we used to have operations teams that do this, but that's all starting to converge into what we call DevOps now, which has become a pretty popular way of delivering software. So serverless is really the spirit of it. Call it whatever you want. There's an entire conference that was called JeffConf because they thought serverless was stupid, and the guy, they said, hey, let's name it after a guy, let's call it JeffConf. Now it's called Serverless Days, go figure. Serverless architecture is when an app is built entirely using serverless components. So serverless is not just compute, it's also storage and networking as well. So for example, Amazon S3 was one of the first serverless storage engines. It was launched in 2006. You didn't think about patching S3 servers. You don't even know that there are S3 servers. You just have an S3 API. So that's really where I think things are going, is towards like an all API world. So functions as a service is really a continuation of an abstraction from bare metal to VMs to containers to functions. It's really about decreasing concern and control and increasing abstraction so that you can worry more about the things that you care about. A function, pretty straightforward. Here are some characteristics that we're seeing evolve or emerge for functions. They're event-driven. They have short duration. They're stateless, and they're lower cost. So short duration, basically meaning if you have a function that runs for 24 hours and you run a bunch of those, then it might actually be more efficient to run a server and to have that thing run this function around the clock. So like really big batch processing, maybe it makes sense to manage your own VMs. But we're actually seeing more and more move towards this architecture where you have shorter durations, large parallelization, large concurrent tasks. The limits on things like Amazon Lambda, I think are 5 minutes, but they may have raised it. But anyways, you're like 5, 10, 15, 20 minutes. You're not like 24 hours. So that's the idea behind short duration. Stateless means you have to think about these things as completely ephemeral. So you don't know where your functions are running, and you don't know where they're going to be instantiated. You don't know what you have access to, so you need to be able to run that thing that's completely stateless. You store your state somewhere else, preferably a serverless storage engine like S3 or a database like DynamoDB or whatnot. I know I work at Oracle. I talk a lot about Amazon. Amazon has the most services on the market today, but so they've sort of created some of these reference architectures for serverless services. And lower cost, you only pay for what you actually run. So the idea is that you can only pay for the milliseconds that your functions are running. That way you get sort of cost model built in. You don't have to think about that. This is a pretty straightforward function. This is an FN function. This is Java. It's very straightforward. You import the FN, what we call the FDK, function development kit, and you have something very simple, which is just hello function, and you pass it an input, and you get back hello, that input. It's basically a hello world function, so nothing too crazy there. But that's basically all you think about. And then the rest is handled by the API and then the system behind the scenes. So functions as a service is taking all of these functions that you write and managing that behind the scenes for you. This is like a end-to-end diagram. I talked about event-driven. I think I actually skipped over that. But event-driven is really important because when a function is not running, there are no servers that are actually serving traffic to that. It's actually, you can consider it like somebody else is using all that infrastructure. But then when an event comes in, it spins up a function which will spin up a container, or spin up a VM, spin up a container, and then load your code and then run your function. But you don't actually see any of that. That's all triggered by an event. So you see event-driven computing commonly sort of in the same sentence as serverless computing. So you have an event source that comes in, triggers a function. That function can run on some stack, but you can generally ignore that entire stack because you don't care about that. And then that can write to some backend service to store the state. That's like the general architecture. So going back to serverless, serverless is taking all that and adding management from like a cloud provider, like Oracle or Amazon or Microsoft. Okay, so the FN project. The FN project is, sorry, lots of words here, but it's a 100% open source, independent of Oracle, functions as a service platform that you can run on any cloud, even your own servers as well, serverless on top of servers. We provide management scripts to run it on top of Kubernetes, or you can launch it on any of the cloud providers. Oracle is obviously going to be launching a managed service called Oracle Functions. We have been not silent about that. It's pretty obvious why we would do that. But we're basing it on the upstream open source code. David in the last talk talked about the importance of community and openness. We also believe that that's extremely important to the future of a lot of this computing. Kubernetes is completely open source, launched from Google. The CNCF houses Kubernetes and a bunch of other projects. Eventually, we potentially see FN as part of that kind of ecosystem of projects. So 100% open source, independent, lots of external contributors, other partners as well that we plan on working with. So it's not just an Oracle project, it's multiple companies that are working on it. And it's basically gives you functions as a service. So it's very simple by design, but we're tailoring it for the enterprise because they have demanding needs. And then it has native cloud events support. If you're not familiar with cloud events, it's basically a way to describe events. That's also a project inside the CNCF. And it's a way of sort of describing the metadata and the payload of event format so that we can have standardization across the industry for how an event travels and sort of what that payload and metadata looks like for an event. We also have something called FnFlow. I might try and show a demo. I have no idea if it's going to work. FnFlow is also 100% open source. That's language-based workflow. We aren't focusing on flow at the moment. We're focusing mostly on FN, which is the FAS, functions as a service. Some of the differentiators of FN, it utilizes open formats, so it's open, container native, enriched by Oracle, which is something that it's important to us, and it has a really great developer experience. Open meaning it's completely open source, has open formats. It's native Docker, so anything that can go inside a Docker container can become your function for FN. And then we have elegant integrations with other Oracle services, but we plan on having those with other clouds as well. And then the developer experience is second to none, so it's a very simple developer experience. Okay, so what does it look like for developers? So an FN function is just a small chunk of code, and we wrap that up in a container image. The way we describe the project is it's the elegance of serverless, but the power of containers. So when you type, and I'll show a demo, when you type fn init, you get a boilerplate, and then when you type fn deploy or fn build, it'll actually build it using a container, and then it will deploy that container to your registry, whether it's Docker Hub or Oracle Registry or some other registry that you're using. And then it gets its input via the FDK, or Function Development Kit, across an HTTP stream. So it gets its inputs by the environment and the HTTP stream, and then it produces some output also as HTTP stream. So you can produce the output back to the caller for a synchronous function, or into a log or something if it's an asynchronous function. And then everything goes to standard error, or you can pipe it through syslog to Papertrail or some other logging service. Because eventually, when you have thousands of functions running, you want your logs kind of aggregated somewhere. And then the FN server and system handles everything behind the scenes. We have a CLI, and this is like the primary developer experience is through the CLI. This is all wrapped around an API. So if fn init, deploy, and invoke are really the only three commands you need to know as a developer, and I'll demo each of those. And then when you invoke it, or when you deploy it, you get back a URL that looks something like this, which is a URL to your trigger. So when you actually do a deploy, actually, I think I have a slide on that. Yeah, this should be updated. So when you do an FN deploy, it will build the container, and then it will bump the version, which is really just a Docker tag. It will deploy, it will send that container to a registry of your choice. You just have to log into that registry, and then it will update the server that you have a new version, and the next time somebody invokes that function, it will pull over the new version. And it will create a trigger. So out of the box, you get an HTTP trigger, so that you can basically get a URL to invoke that function. Eventually, we'll have other trigger types, so you can create a trigger for like Kafka stream, AMQP, queue, or something else. And so triggers kind of separate how you invoke a function from the actual code itself. Debugging, as a developer, is pretty straightforward. If the top bullet is an FN update app. Well, Cloud Events is the name of the app, so this is just an example. But you give it a syslog URL, and it'll send all of your data to Papertrail. That way, you get all of your logs, and you can see them. You don't have to go in and do like FN get logs and then find the ID of your function and all that. You just get them all streamed to Papertrail or any other syslog destination. And then metrics are created using open tracing. So we integrate with anything that's basically set up as a collector for open tracing. There's extensions for Prometheus and Zipkin and Jaeger. Prometheus is sort of the gold standard right now for for monitoring and observing things coming into Kubernetes systems, and that's what we use for through open tracing. So I talked about FDKs. The FDKs are basically a way to initialize your function, and then it parses the input as it comes in. So it sort of takes out all the magic behind the HTTP stream, which is a lot of boilerplate code. It's familiar syntax if you're a Lambda developer, and it gives you basically a simple handler. I'll show you an example of doing fn init that will sort of give you all that boilerplate out of the box. And so really, it makes it a lot easier to build functions. And hot functions are the reason that we do it this way, and we used to do standard in, but when you use standard in, it makes it hard to keep a function hot. And by hot, I mean when you spin up a function, it stays active, responding to traffic, such that you don't get what we call a cold start. A cold start for a function is when you have to spin up a container and then load your code, and it can take like 20 or 30 seconds. It can take multiple minutes, actually. And that's totally unacceptable if you're waiting for a response from that. So a hot function is intended to keep it running just long enough to continue serving traffic until it senses that there's no more traffic, and it says, okay, I'm gonna go away. These are the languages that we support today for FDKs, but again, you can bring your own container, so you can use any language you want, really. And then there's a UI, which I believe might be currently broken, but pull requests, we'd love that, but we're going to fix it pretty soon. We made a bunch of changes and just released what we call the V2 API, so we have to just quickly update the UI as well. But open source, yay. I'm going to breeze through, actually, no, I'll show a demo. Hopefully this will work. Where are we? All right. So I'm actually going to just show you. So, okay. I'm a fresh developer. I haven't used FN. If I'm on a Mac, I just do brew install FN. This gives me the CLI. Wait, can you guys see? How's that? That's all you need to do. You get the CLI, and boom, you have FN version 0520 installed. Next thing you do, FN start, and that gives me the server. So now I'm running it locally. When you deploy this into production, it's a little more, when you use like a Helm chart to deploy it on top of Kubernetes, it's a little more involved. It's basically this server, but it's deployed in a configuration with a load balancer in front of it. I'll show you a slide for that. But this is like local development. So now I've got the FN server running locally in a tab on my laptop. Next thing you do, which I'm not going to, is set up a context. Context is essentially pointing your CLI to where the what server you want to talk to. Sorry for the weird output here, but if you look, I have 4 contexts: default, local, OCI PHX, and OSS service. Those contexts, default is local, local is also local. OCI Phoenix, that's our service running in our Phoenix data center. And then OSS service is running in our Frankfurt data center, which is just like our OSS code launched. It's not like our managed service, so it's something that I launched. Then you do FN use context local, but I'm already using it, but it's already in use. So now I'm talking to the local host. You don't have to do any of this because out of the box it will come already pre-configured for localhost. And then I do FN init, -- runtime Go or Java or Python or Ruby or Node. And then you got to give it a trigger. So HTTP trigger currently is the only one supported, but it's set up for pull requests for other ones. And then I give it a name. I'm going to call it hello. So that created a directory, and I basically have 3 files. Oh yeah, it's real big. Cool. Func.yaml is pretty straightforward. It's got a schema version. The name of it is hello. It's 0.0.1. Format is HTTP stream. That will the format will probably go away, so you can just ignore that part of it. And then the trigger is hello trigger with type HTTP. So then I can do, I have to do fn deploy -- app demo, and I don't know if I'm on the internet. I can do it locally. But so this is building the container. So it bumped it to 0.0.2. And it takes a second. And if I'm on the internet, it will push it to, oh, you logged into Docker. I'm going to do it locally. Sorry. So this is actually trying to push it to Docker Hub in the US, I think. But if I do -- local, it'll skip that step. And it will just use the container that it builds locally on my machine. The beauty of being container native is that you get the same artifact every single time. So you can run that artifact through CI/CD system, or you can use it for things like security scanning, using things like Black Duck or whatnot. Any of the tooling and ecosystem around containers you can use for your function container. So then now it's building the container again. It bumped it again, and it will not push it to Docker Hub. I'm just going to sit silent, so this is awkward. I don't know what's... Come on, buddy. You can do it. There we go. All right. So it created app demo, and then it created the function hello, which is just Arimura hello. So if I docker do images, grep Arimura hello, I probably have like a ton of them in here. So these are all like my hello images that I've created over. I need to clear my machine of these Docker images, but these are just Docker images. So I just did a simple Docker image. So this is local. And then it created this endpoint here. So in theory, I should just be able to take this endpoint. I don't know where my browser is. And I can just go here, and I've got hello world. I can also do fn invoke demo hello, and this will give me back hello world. I can also do echo co-motion audience, and I can. So you'll probably imagine what this will do. Oh wait, echo. Sorry. Invoke demo hello. Wait a minute. Why did that work? Well, that's weird. Let's check. So it's supposed to receive on a struct, and then it outputs, and it codes it. I don't know. I'll check that in a minute. But so I can also go in here and change the type to a Dockerfile. And if I have a Dockerfile in here, it will just build any custom image, and it'll make that my function. So that will make it so that you don't actually have to use any of our FDKs. You can just use any Dockerfile off the shelf, which is really powerful because a lot of some dependencies are really, really hard to build. So if you use something like ImageMagick or some kind of like image detection or sentiment analysis, these libraries are pretty complicated, but they create Docker files for you to get started really easily. So you can take those off the shelf, you can make that your function, and you're off to the races. So I can do my list functions demo, and I've got Arimura hello 0.0.3 with an ID there. I can do fn inspect functions demo, or sorry, fn inspect function demo hello. And this will give me the information about my function. So I get my, it has an invoke endpoint, which is an endpoint we generate for you. It's like a not pretty one. And then its formats HTTP stream. You can change the memory by updating it to, let's say, 256 or 512 or a gig. You can actually make this anything. So however much memory your servers behind the scenes have, you can utilize that as much as you want. That's the dial that you can kind of control for your function. Eventually, I see potentially doing like automated profiling for how much memory you need so that you can not have to worry about configuring that. But for today, you basically configure that. That's one nice thing about running your own FAS is that you can sort of have unlimited memory, whereas if you use one of the cloud providers' managed service, they only give you a certain amount to use. Okay, so just a couple slides real quick on operating. Oh, sorry. So the architecture looks a little bit like this. It's the same image for the FN server, but when we use the Helm, if you look at our Helm chart, which if you go to GitHub/FN project/FN Helm, it's fairly straightforward. It will launch the server with the tag for the LB, and then it'll set up a number of servers, and then you can use any data storage for your data. So you can use things like Postgres or MySQL or Oracle DB. It's pluggable. For your MQ, you can use Redis or RabbitMQ, I believe. I think there's a pull request open for Nats. And then object store can be anything that's S3 compliant. So Minio, I think, is the preferred one today. But you can use any storage engine for that. And then a container registry, you can use anything locally, or you can use Docker Hub for your system. I will skip these slides. The runner LB is, if you set the environment variable to fn node type equals LB, this will spin up the server as a load balancer, and essentially that's geared for continuing to send traffic to like the right node. Again, these are things that you don't really have to worry about. If you use the Helm chart or somebody operating it can just stand it up, or you use the managed service, you don't have to worry about any of this stuff. I do understand that there's like a big debate about the term serverless and stuff that you have to go install onto servers, and so there is that. I understand that, but it looks serverless to the developer, and also eventually the cloud providers all just offer these things so that you don't have to think about it and nobody has to operate it. That's the idea of undifferentiated heavy lifting. There's a lot of reasons to pick up an open source project though, because you can dive into the code. The runner LB basically scales out the system for you. I won't go into this, but I can pass around these slides so that everybody can see exactly how it works. Supporting services, I talked about this. Deploy to Kubernetes gives you the Helm chart, so pretty straightforward. You can use like a Kubernetes engine service from any of the providers, like EKS, I think, is Amazon's. Oracle's is called OKE, lots of acronyms. You can spin up a Kubernetes cluster, then run, you basically just do Helm install, I think, or kubectl apply -f, and then give it this Helm chart, and boom, you've got your cluster stood up. Stuff that you get out of the box with Prometheus is a bunch of stats. Cool. Use cases. So I get this question a lot, so I like to cover a couple use cases. Ironically, one of the lowest hanging fruit use cases for serverless today is automation and DevOps. You think like serverless is supposed to get rid of DevOps. It doesn't. It actually enhances it. One of the speakers said, it doesn't replace people. It's machines plus people. That's what serverless is. It's kind of machines plus people. So for DevOps, you can do really cool things. Like any of the cloud providers, they have native hooks between all the different events that happen in the system and the functions that you build. So again, like on AWS, object goes into a storage engine. You can trigger a Lambda function. Same goes for Oracle. Or like there's a state change in one of your security profiles. You can run like tests across that to ensure it was intended. Or for example, if you launch a new server, somebody in your org launches a new server, and maybe it doesn't have the right tags associated with it to do a cost model back to the department that launched it, kill it. Well, we have a lot of customers where that's like the most simple freaking use case, but it's great for something like serverless because it's all kind of wired together and you don't have to launch servers and deal with that stuff. So that's like the lowest hanging fruit in your organization. If you want to kick the tires with serverless, this is a great place to start. But you might not be in DevOps, so there's other things you can do. I won't cover this slide, but we've got this whole strategy at Oracle around extending and enhancing Oracle applications. If your organization is using any Oracle applications, we can automatically receive event streams from those applications to sort of unlock functionality from those apps and spin up functions on the Oracle Cloud. IoT is a big one where devices are sending data in to some kind of a stream service. Stream service is integrated with functions, and you can automatically spin up and do kind of processing on that. Mobile backends, stream processing, file processing, really cool use cases for serverless. Batch is another one. A lot of our customers have like these really unwieldy kind of batch processes in the background. You can move that to serverless and get rid of the heavy lifting of all the servers. Final thing I'll show is what we believe could be kind of the future of orchestration and workflow. This is something called FnFlow. FnFlow is a way to build workflows. So functions don't live in isolation. Oftentimes they need to trigger other functions, or there's some kind of parallelization of functions and you want to bring them all back together and get to a result. Because they're stateless, you need something to act as like a state machine for that. It's actually really hard to do this with serverless functions today. A lot of the providers have things like step functions, which is what Amazon offers. It's really a nice way to declare long programmatic workflows using JSON, but like no sane developer really should be writing JSON. So that's why we believe that it should be done in the programming language of your choice. That's what FnFlow is. It allows you to build those workflows. We chose Java as the first language to support, and we implemented it around Completable Future API. So it looks a lot like, or actually I'll show you code in a second, but it looks a lot like this. So I took these 5 functions that I have for a demo called Vista, which did image recognition or license plate recognition, and then tweeted those and slacked it. Those were a bunch of functions that I had kind of wired together. We took those, replaced it with code like this, moved it to a function called a flow function. Now you've got like these nice kind of completable feature, then compose, all of, when complete blocks. And it makes it a really nice way to build workflow. This is probably really small, but the code is like 30 lines and it looks a lot like this. Create a future object. You invoke the scraper, which is my function that does scraping off Flickr. And then it composes a number of functions, detect plates, draw. And then it will do an all of, which is like a parallelization into Twitter and Slack. And then when complete, which is actually really hard to do in serverless because these things, you could have like thousands of functions running. You have no idea when they're going to be complete. Well, Flow does something really simple. you get when complete, and when that's done, it will give you an error or a finish scraping. I'm going to try and demo it, but Flow, to be honest, it's totally experimental. We built it a year ago, and we haven't touched it much, and because we just launched the second API, version 2 of the API, it may not work, but I'm going to risk it anyways. Oh, shit. You know what? I need Slack open. 2 minutes? Do I have 2 minutes? 1 minute. Okay. It's going to take a minute to run this thing. Or open Slack, because Slack is freaking slow. Hopefully I'm not talking shit about all my bosses and stuff. Just kidding. Oh, well, that's the result. But anyway, so if I go into services flow, I can see. So this is what the payload looks like. It basically sends Flickr a query, gets back a 10 results, and then so if I do cat payload.json fn, actually I think I probably have it, invoke Vista Flow. I really have no idea if this is going to work, but what I do is I get a graphical representation of those functions running. So I'm actually querying Flickr for 10 different cars, and then I'm running them through a series of pipelines to get back what the license plate is on each of those cars, and I'm going to tweet it and Slack it. These are IDs. This just changed. These actually should be the function name itself. We're going to bring that back, but because the system changed, it's kind of awkward. You can click on any particular node, which is a single function, and you can actually see back how that function was called all the way back to the beginning. Again, these IDs should be names, so you'd be able to tell that like detect plates was called by draw, was called, or previous to draw was called by scraper, etc., and the logs would be in here. And then if any of them are actually working, we start to get cars in here, which looks a little bit like that, but it takes a little while to run the system because I'm running it locally on my computer, which is kind of weak. And it looks, so you can see it's still running out here. And there's a couple errors, so you can go in here, you can get the ID, I can look in paper trail what that looks like. It's probably running out of memory because I'm running a bunch of stuff. But if it were to work, it would look a lot like this, and it would spin up each of these cars pretty quickly. And you can see it works pretty well. All of this code is open source, so if you want to try this stuff out on your own, you can. It's using a number of like open ALPR libraries and stuff off the shelf to do image recognition, image magic to do the drawing of the box, and so I can go in and change a bunch of these things on the fly. So it's pretty neat. Again, obviously, I have to preface it with like this stuff is all pretty experimental, the flow stuff, but we'd love to get community support around this because we believe this is where a lot of workflow is going. Yeah, that's it. Thank you for coming.